Welcome. My name is Eric Brandsburg, CTO of Heimdall Data. Today I'm going to very briefly introduce Heimdall and how it can be used with Pivotal Greenplum in order to provide automated failover as well as query caching to improve performance. First off, what is Heimdall? It is a database proxy that sits between your application and database and provides a variety of features. First, it provides database monitoring and scripted failover orchestration. Second, it provides caching into Gemfire or other cache engines as desired. Third, it provides analytics to allow poor performing queries to be identified. There are actually a number of other features that Heimdall also provides, but for the context of this video, I will demonstrate these three features, including their configuration. The first use case, that of automated failover, allows Heimdall to detect when the master node of a Greenplum cluster has failed, and to execute a script as a result. This script then triggers the promotion of the standby node and disables traffic for the primary, ensuring that only one node is online at a time. For the second use case, that of caching, we will use the psql command to connect to Greenplum and demonstrate the caching as repeated queries are made. One interesting point about Heimdall's caching is that invalidation logic is automatic. You don't need to configure complex rules for cache invalidation to occur in most cases. Instead, Heimdall parses DML queries and automatically accounts for them when serving results from the cache. Further, in order to reduce the latency impact of an external cache, Heimdall keeps a local hot cache in memory and also tracks the keys that are present in the external cache. This means that even on a cache miss, no additional latency is added to the query. Instead, it is pulled directly from the database. Finally, as part of the caching demo, I will also introduce the Heimdall Analytics capabilities. In order to set up the environment for our demonstration, I have prepared a Linux server, a 5-node Greenplum cluster via Docker, a Gemfire instance, and an unconfigured Heimdall instance. To start our demonstration, I will connect to the Linux instance on port 8087, and then I will use the Heimdall configuration wizard to configure the Greenplum cluster with Gemfire as the cache. You'll use the manual configuration option to start the configuration. Next, enter the configuration information for the master node of the Greenplum server. On the load balancing tab, we will skip the configuration of load balancing. Because Greenplum doesn't support an active-active or read-only standby server today, it'll be easier to configure this portion manually later. Next, in the caching section, select the cache type of geode/Gemfire and enter the required information. Following the cache section, we will configure Heimdall to operate as a proxy. The alternative, which is used exclusively for JVM applications, is to operate as a JDBC driver. In the Properties section, we will accept the default behaviors to enable logging, connection pooling, query plan extraction, and to provide a default cache policy. After the properties, a summary of all options selected will be presented. Select Next to bring up a list of additional instructions that may assist later in debugging. Finally, submit in order to create the configuration in Heimdall. At this point, access to Greenplum is configured. However, failover is not yet complete. Next, we will switch to the Data Sources tab, expand the Load Balancing section, and enable load balancing. Now we can set up the standby server and configure our failover script. We'll use a script that is included in the Heimdall distribution package specifically for Greenplum in order to enable scripted failover. With this change, the complete configuration has been made. We now have scripted failover as well as caching with analytics available for us to demonstrate. For the feature demonstration, we will first connect using psql and perform a few queries which will illustrate the impact of caching. Next, we will look at the analytics, and finally, we will demonstrate a failover. To start off, we will first switch from our status screen to our dashboard and observe queries in real time. Next, we will connect with pSQL and enable query timing. Our proxy is accessible via localhost on our Linux instance, and we can connect using the same credentials we entered for the database via the wizard. Once connected, we will issue a first query against the database which has been pre-populated with sample data. Notice the response time on the first query and that the dashboard doesn't show any cache hits. We can then issue the same query again, and this time being retrieved from the cache and with a much faster response time. We can now switch to the Analytics tab and observe the impact of cache hits versus misses here as well. In addition, we can expand the query and observe the query response time as well as the extracted query execution plan, which was retrieved from the Greenplum server as well. We will now go back to the dashboard in order to monitor the query health statistics. From here, we will trigger a failover with Greenplum by terminating the Docker instance the master node is running. While the master node is immediately terminated and our scripts trigger the promotion of the standby to master, with Greenplum, the actual promotion may take some time. In our setup, this can take between a minute and a minute and a half. During this time, requests made on active connections will be held for a period of time based on the hold time configured in load balancing. In our configuration, I have set this to be 2 minutes to ensure the entire failover can be done without queries failing. At this point, the standby node has taken over and is now able to process traffic, as observed by using pSQL again. This concludes our demonstration showing the configuration of Greenplum with Gemfire, caching and failover, all facilitated by Heimdall Data. If you have any questions about this integration, please contact Heimdall Data via our webpage at www.heimdalldata.com. Thank you.